Welcome to the Architect of a Dream channel. Today, we will journey to distant suns that hold in their fire the secrets of the worlds they have consumed. We will become silent witnesses to a cosmic drama unfolding over millions of years. We will see how stars, the givers of life, become silent predators at the end of their path, taking back what they once created. This is not a story of cruelty, but of the great cycle of the universe, of the eternal dance of creation and destruction. It is a lullaby written in the light of dying stars and the shadow of vanished planets. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and your mind soften. Let us begin. In the very heart of every star lives a quiet, steady fire, a promise of stability for billions of years. For most of its life, a sun is like a perfectly tuned instrument playing the same note, warming its planets with a steady, predictable light. This time is called the main sequence, a long, calm exhalation of the star, during which the hydrogen in its core slowly turns into helium. In this state of equilibrium, worlds are born and flourish, bathed in the light of their parent. This is the golden age of any planetary system, an era of peace and slow, unhurried development, when life can put down its fragile roots, trusting its star. This is a golden time when the universe seems kind and infinitely predictable. But this peace, like everything in the universe, is merely a temporary respite before an inevitable change. And this change begins with an almost imperceptible internal shift, like the first grey hair in a thick head of hair. When the hydrogen fuel in the star's core runs out, gravity, the eternal adversary of stellar fire, begins to slowly but inexorably win. The core contracts under its own weight, becoming denser and hotter, while the outer layers of the star, on the contrary, begin to swell like a deep, slow breath before a final word. This is the beginning of the end of a long, peaceful life, and the prologue to a great transformation. The star enters its autumn, preparing to become a red giant, and this process, taking millions of years, is as inevitable as the changing of the seasons on Earth. The star begins to forget its former boundaries, expanding into the cold void of space. Imagine a star that suddenly begins to grow, increasing in size 100 or even 1,000 times like a shadow gaining flesh. A red giant is not just a large star, it is a swollen ghost of its former self, bloated by internal changes. Its surface cools, acquiring a deep crimson hue, like embers in a dying fire, but its overall luminosity increases many times over due to its colossal size. It becomes like a huge dim lantern, filling the entire planetary system it once carefully warmed. The planets that orbited at a safe distance now find themselves dangerously close to the swelling surface of their sun. Their familiar sky turns into a wall of fire. The sky is no longer blue or black. It is a solid, oppressive, slowly advancing fire. Our own sun will one day undergo this transformation, becoming an immense red giant whose boundaries will engulf all that was close. In about 5 billion years, its expanding photosphere will swallow the orbit of Mercury, the planet closest to it. Mercury, a scorched rocky desert, a perpetual recluse at the very heart of the system, will be the first to face the fiery tide. It will not simply burn, it will evaporate, dissolve into the star's plasma, becoming part of its substance, like a drop of dew in the ocean. It will be a quiet, almost unnoticeable finale for the rest of the galaxy, the end of a long story of a small world that spent its entire life in the shadow of its future killer. Its metallic core will momentarily enrich the star's composition before disappearing without a trace. Thus, the first child of the solar system will return to the fiery womb of its parent. Next in the path of this fiery deluge will be Venus, shrouded in its dense poisonous atmosphere as if in a burial shroud. Its fate will be just as inevitable and silent. The expanding sun will first blow away its thick sulfuric clouds, exposing a white-hot surface, and then pull it in and consume it whole without a remnant. Venus, named after the goddess of love, will disappear into the embrace of the star that once gave it light and warmth, turning it into a hellish greenhouse. This act of cosmic cannibalism is not a manifestation of ill will, but merely a consequence of the fundamental laws of physics that govern the life and death of stars. A star does not choose its destiny. It merely follows the predetermined path of its evolution. Its expansion is not aggression, but the dying breath of an aging giant. The fate of our own planet, Earth, hangs by a thread, on the fine edge of astrophysical calculations and model inaccuracies. According to some scenarios, the expanding sun will stop just short of Earth's orbit, incinerating it to a state of slag, but not physically consuming it. According to others, which are more probable, our planet will still be captured by the outer, rarefied layers of the red giant. If this happens, Earth will begin to slowly break in this incandescent atmosphere, moving in a tightening spiral toward the star's center. The oceans will boil away, the atmosphere will be stripped, and the very solid ground of the planet will melt and dissolve into the solar matter. Our home will become but a fleeting flash in the agony of its star. The memory of humanity, of forests and cities, will dissolve in the streams of the solar wind. Even if Earth avoids direct engulfment, its fate will be unenviable and devoid of all hope. Situated at the very edge of the fiery sphere, it will turn into a scorched, lifeless ball of lava, tidally locked to its tormentor. The surface temperature will reach thousands of degrees, and the intense solar radiation will sterilize everything that could possibly remind of former life, down to the last microbe. The planet, if it survives, will do so only as a charred skeleton, a silent witness eternally orbiting a dying star. It will be a world where sunrise means not the beginning of a day, but the fiery end of all existence, filling the entire sky from horizon to horizon. It will become a silent monument to what was once a blue pearl of the cosmos. The process of a planet's engulfment is not an instantaneous event, but a slow, agonizing dance stretched over millennia. When a planet enters the outer, most rarefied layers of a red giant's atmosphere, it begins to experience immense drag. It is like a stone falling into very viscous thick water, only instead of water, there is plasma heated to thousands of degrees. This constant friction slows the planet, causing its orbit to shrink with each revolution. With every turn, it plunges deeper and deeper into the fiery depths, doomed to fall into the very center of the star. This spiral path can last for thousands of years, turning its demise into an endless agony. It is a slow fading, stretched over a geological eternity. Before the planet is completely submerged in the star, it is torn apart by monstrous tidal forces. The star's gravitational field is so much more powerful on the near side of the planet than on the far side that this colossal difference in gravitational pull literally stretches and shatters the celestial body. Rocks, continents, entire hemispheres are torn from the planet and swept away into the fiery vortex of the stellar atmosphere. The planet turns into a stream of debris, into a ring of its own substance, which spirals towards the star's surface. It is similar to how a comet disintegrates near the Sun, but on the scale of an entire world, and in the conditions of an infernal furnace. The planet dies, turning into its own funeral wreath of dust and rock. For gas giants like our Jupiter, the scenario may be different, but no less dramatic and spectacular. As they approach the bloated red giant, the powerful stellar wind and unbearable heat begin to strip away their atmosphere, layer by layer. The vast cloud belts, hydrogen and helium, accumulated over billions of years of patient growth, are carried away, forming a gigantic tail, similar to a comet's, but millions of times larger. The gas giant loses weight, shedding its mass, and in the end, all that may remain is a dense, scorching, rocky metallic core, which will make the final plunge into the stellar abyss. The star peels off its child's layers one by one before devouring its heart. It is like the slow, merciless undressing of a planet before its complete disappearance. We are not just theorizing about these cosmic meals. Astronomers see their traces throughout the galaxy, like detectives studying a crime scene. One of the most telling pieces of evidence is the presence of an element in a star's atmosphere that should not be there: lithium. Lithium is a very fragile element. It burns up quickly at the high temperatures inside a star. Therefore, when astronomers see an old star with an anomalously high lithium content on its surface, it almost always means one thing: the star has recently dined on a planet. Planets and asteroids are rich in lithium, and when one of them falls into a star, it pollutes its surface with this element, leaving a clear chemical clue. It is like a fingerprint at a crime scene, visible across the abyss of light years. This lithium anomaly is not just a beautiful theory, it is confirmed by observations. The star HD 2404 Thrucio, unofficially named Kronos, after the Titan from ancient Greek myths who devoured his children, is the most striking example of this. Its composition shows an excess of elements that make up rocky planets: iron, silicon, magnesium, and of course, that very lithium. Analysis shows that over its lifetime, it could have absorbed matter equivalent to 15 Earth masses. A companion star, Krios, orbits nearby, and its composition shows no such anomalies, which proves they were not born this way. This suggests that Kronos is indeed a world eater. Two stars born together from the same cloud, but with a completely different, sinister history. Besides lithium, there are other chemical ghosts of consumed planets that reveal the star's secret. These are heavy elements that under normal conditions should have long since sunk into the star's deeper layers under the influence of its gravity. When astronomers, using spectroscopy, see an unexplained excess of iron, aluminum, or nickel on the surface of an old star, it is another sure sign of a recent engulfment. A planet, falling into a star, acts like a giant spoon that stirs its outer layers and brings to the surface what should have been securely hidden in its depths. A star cannot hide the traces of its feast. They are written on its face in the language of light. Another subtle but sure hint of stellar cannibalism is the star's own rotation speed. When a planet falls onto a star in a spiral trajectory, it transfers its angular momentum to it, causing it to spin faster than is typical for its age. Imagine how a carousel spins up if you jump onto it with a running start. In the same way, an old, slowly rotating star can suddenly rejuvenate, accelerating its rotation after absorbing a massive planet. Astronomers, finding an abnormally fast-spinning red giant, always suspect that the cause is a recent meal that disturbed its senile peace. A falling planet leaves behind not only a chemical trace, but also a swirling vortex. The star Arzu Piscium in the constellation Pisces presents another intriguing mystery pointing to the engulfment of planets. This star periodically and chaotically dims, which is completely uncharacteristic for its type and age. Detailed observations have shown that it is surrounded by a huge, dense cloud of dust and gas. The most plausible hypothesis states that we are observing the direct aftermath of the destruction of one or more planets, which were torn apart by the star's tidal forces very recently in cosmic terms. This dust is all that remains of entire worlds, and as it orbits the star, it periodically blocks its light, creating these strange flickers. We are not seeing the meal itself, but its consequences, the dust from the planet's crushed bones. Sometimes a star betrays itself with an excess of infrared radiation, invisible to the eye, which is synonymous with heat. When a planet or a large asteroid is destroyed and its debris begins to fall onto the star, it heats up significantly and begins to glow brightly in the infrared spectrum. This heat signature can be detected by our telescopes. It indicates that there is a disk of hot dust around the star, the remnants of a recent feast. It is like the heat left over from a campfire that has already gone out, but the embers are still glowing, revealing its presence in the silence of the night. Cosmic dust around the star glows with the ghostly heat of a destroyed world. Not only old giant stars can be cannibals, sometimes this happens right at the dawn of a planetary system's formation. Young stars are surrounded by protoplanetary disks of gas and dust, in which planets are born as if in a cradle. In this chaotic dance of gravity, some newborn planets can begin to spiral inward, toward their star, due to complex interactions with the surrounding disk. Before they have even properly formed, they fall into the embrace of their young sun, becoming mere additional fuel for its burgeoning fire. Their life ends before it has begun, like a flower plucked before the first dawn. This process, called planetary migration, helps to explain why we find so many hot Jupiters, enormous gas giants, orbiting in insanely close, scorched orbits around their stars. Many of them are the lucky survivors who, for some reason, halted their fall at the very last moment. But for every such survivor, there are likely several who are not so lucky, and who ended their journey inside the star. We only see those that manage to hold on at the very edge of the fiery abyss. Their close, scorched orbits are scars, reminders of the mortal danger they survived. Even after a star's death, its ghostly cannibalism can continue, taking on new, colder forms. When a star like the Sun exhausts its fuel and sheds its outer layers, what remains is an ultra-dense core, a white dwarf. This is the cooling corpse of a star, the size of Earth, but with a mass comparable to the Sun's. It would seem that this is where it should all end, but the white dwarf's gravity is so strong that it can continue to influence the remaining planets and asteroids in the system, pulling them toward itself. A star's death is not the end of the story, but merely the beginning of a new, ghostly and quiet chapter. Astronomers have discovered many so-called polluted white dwarfs, which serve as silent evidence. Their atmospheres, which should theoretically consist solely of pure hydrogen or helium, contain heavy elements, calcium, magnesium, iron, silicon. These elements could not have formed in the white dwarf itself and would have long since sunk into its depths. The only way for them to get there is from asteroids or planetary fragments falling onto it, knocked from their distant orbits by gravitational perturbations after the star's death. The white dwarf, like a cosmic archaeologist, collects on its surface the remnants of its former system. It wears on its face the ashes of its dead children. The star WD 1145+17 is a unique system where we are observing this gruesome process in real time, as if looking through a window at someone else's tragedy. Around this white dwarf orbit, the fragments of at least one destroyed planet or large asteroid. Astronomers see these fragments pass in front of the star, causing regular dips in its brightness, and how dust from these fragments is slowly but surely settling onto the white dwarf's surface. It is like a cosmic autopsy, allowing us to see how a dead star continues to feed on the remains of its own past. It is a planetary graveyard where we can observe the unhurried work of a cosmic gravedigger. The incredible gravitational force of a white dwarf can tear even a large asteroid or a small planet to shreds if they approach too close to the Roche limit. Tidal forces stretch the unwary object, turning it into a cloud of dust and gas, which then forms an accretion disk around the white dwarf. This disk slowly spirals down onto the star's surface, polluting its pure atmosphere with heavy elements. Thus, even after its official death, the star continues to methodically collect tribute from its ruined and cooling empire. The ghost of a star still possesses enough power to destroy entire worlds. By studying the chemical composition of these pollutants on white dwarfs, scientists can, like paleontologists with bones, reconstruct the chemical makeup of the planets they have consumed. For example, a high content of oxygen and magnesium might indicate that the absorbed object was rich in water, or that it had an iron core and a silicate mantle, similar to Earth's. This allows us to peer into the distant past and learn what the planets in that system were like before their star died and began devouring their remains. A dead star becomes a priceless archive, preserving the chemical memory of lost worlds. Some stars seem to have a truly insatiable appetite, which is imprinted in their current configuration. The star BD Plus 48740 is an old red giant that not only exhibits an anomalously high lithium content, but also has a giant planet orbiting it in an unusually elongated elliptical orbit. Scientists speculate that this surviving planet is the sole witness to the demise of its sibling. The absorption of an inner planet caused a powerful gravitational push that ejected it into such a strange, elongated orbit. It is a lonely orphan, eternally circling over the invisible grave of its sibling. Sometimes the absorption of a planet can have visible, almost explosive consequences that can be observed even from a vast distance. If a sufficiently massive object, such as a gas giant or a brown dwarf, falls onto a star, it can trigger a powerful flare. The release of colossal gravitational energy as such a body falls heats the star's matter and causes a bright, albeit brief, increase in its luminosity. Astronomers are actively searching for such events to catch a star red-handed at the very moment of its cosmic meal. It is like the splash from a stone thrown into a pond, visible from trillions of kilometers away. This process can also explain some mysterious stellar flares that do not fit standard models of stellar evolution. For example, the so-called luminous red novae are a type of stellar explosion that is significantly weaker than supernovae but brighter than regular novae. One of the leading hypotheses suggests that some of them may be caused by the merger of two stars or, in rarer cases, by a star absorbing a very massive planet or a brown dwarf. A dying planet makes its killer star shine one last time with particular brightness. Stars in binary systems can be particularly ruthless cannibals, where the drama unfolds according to a more complex script. The gravitational interaction of the two suns creates a chaotic, unstable environment for any planets unfortunate enough to be born in such a system. A planet can be easily knocked from its stable orbit and either ejected from the system into cold interstellar space or sent on a collision course with one of the stars. Such systems are true gravitational billiard tables, where planets are merely balls. Planets within them are like billiard balls, their fate depending on a random strike. If a planet orbits one star in a close binary system, then when the second star passes by in its orbit, it can steal that planet, pulling it towards itself. Or even worse, its gravitational perturbation can disrupt the delicate balance and send the planet on a slow spiral into the embrace of its own sun. The second star in such a scenario acts as an unwitting catalyst for tragedy, a trigger for catastrophe. She is an unwilling accomplice in the crime committed by her stellar neighbor. Asteroseismology, the science of studying starquakes, gives us another subtle tool for detecting consumed planets. Just as seismologists study the Earth's interior by the propagation of waves from earthquakes, asteroseismologists study the internal structure of stars by their natural vibrations and pulsations. The fall of a large planet into a star can cause powerful oscillations that change the sound of the star. These changes, though subtle, can persist for thousands of years, revealing the star's turbulent past to one who knows how to listen. A consumed world leaves behind not only a chemical trace, but also a long echo, trembling in the heart of the star. But not all planets are doomed to perish in fire. Those in sufficiently distant orbits, like our gas giants Jupiter and Saturn, will likely survive our Sun's red giant phase. They will watch the agony of their star from a safe, cold distance, continuing their slow, majestic dance in the cooling cosmos. Their orbits may change slightly under the influence of the changing gravity, but they themselves will survive, becoming the heirs of an empty system. They will become the silent, icy guardians of the fading solar system. When a red giant sheds its outer shells, forming a beautiful but ephemeral planetary nebula, and shrinks into a white dwarf, a completely new era begins for the surviving planets. They begin to orbit the tiny cooling remnant of their former star. The sky for a hypothetical observer on a moon of such a surviving Jupiter would look completely different. Instead of the huge bright disk of the sun, there would be only a tiny but dazzlingly white point of light, giving almost no heat. The era of warmth and light is replaced by an eternal night, illuminated only by the ghost of a former sun. Moreover, there is indirect evidence for the existence of second-generation planets, born from the ashes. These are worlds that formed from the material ejected by the star during its death. The gas and dust of the planetary nebula, enriched with heavy elements from the star's interior, can eventually condense into a new protoplanetary disk around the cooling white dwarf. From this disk, like a phoenix from the ashes, completely new planets can be born. On the ashes of an old world, a new, completely different life can arise. Pulsars, rapidly rotating neutron stars, the superdense remnants of massive supernovae, can also have planets. which seems completely impossible. The first exoplanet in history was discovered around the pulsar PSR B.1257+12. These pulsar planets are true cosmic phoenixes. They could not have survived the supernova explosion that created the pulsar itself. This means they formed later, from a debris disk left over after this unimaginable cataclysm. They are children of primordial chaos, born from the remains of an exploded star. Thus, stellar cannibalism is not just an act of total destruction, but also an integral part of the great cosmic cycle of recycling matter. The elements that made up the consumed planet do not disappear without a trace. They mix with the star's material, and then, when the star dies, are scattered into space as part of a planetary nebula or a supernova explosion. This enriched material becomes the building blocks for new stars and new planets. The ashes of one world become the fertile seed for another, future world. All the matter that makes up you and me and our planet was once part of stars. Heavy elements, such as the carbon in our cells, the oxygen we breathe, and the iron in our blood, were forged in the nuclear furnaces of stars that lived and died long before the sun was born. In a way, we are all made of recycled stardust. And when a star consumes its planet, it is merely taking back what was once part of its stellar predecessors. It is the great cycle of matter in the universe, with neither beginning nor end. Imagine a star that remembers its eaten planets, like an old man remembers his youth. Of course, it has no consciousness, but its chemical composition, its rotation speed, its internal structure, all bear the indelible imprint of its turbulent past. By studying the star, we can read this history, written in the universal language of physics. Each anomalous line in its spectrum is like a line in a book, telling the fate of a long-vanished world. These are so subtle that they are almost impossible to notice, like a whisper in a noisy room. A small, barely perceptible change in the periodicity of the star's pulsations, a slight shift in its spectral lines that could be written off as an error, a barely noticeable asymmetry in its magnetic field. All of this could be a quiet whisper from the past, a hint that the star was not always alone in its current form. Astronomy is the art of listening to this cosmic whisper. It is the art of discerning the voices of dead planets in the silent choir of starlight. The consumption of a planet can even affect the further evolution of the star itself. The additional material, especially if it is rich in heavy elements, can alter the processes occurring in its core and affect its life path. It can slightly extend or, conversely, shorten its life, change its temperature, or its final luminosity. A falling planet is not just a drop in a fiery ocean. It is an event that can change the very nature of that boundless ocean. Even a giant feels the fall of a grain of sand, if that grain of sand is an entire world. There are intriguing hypotheses that some blue stragglers, stars in globular clusters that appear anomalously younger and hotter than their neighbors, owe their youth precisely to cannibalism. They could have either merged with another less massive star, or sequentially absorbed several large planets, which rejuvenated them, adding fresh hydrogen fuel and causing them to burn brighter and bluer than their age would suggest. They are cosmic vampires, extending their lives by consuming others. As our detection methods become more and more precise and sophisticated, we are finding more and more candidates for cannibal stars. What once seemed like rare and frightening exotica now appears to be a commonplace almost routine part of the life cycle of many, if not most, planetary systems. Death in the fiery embrace of its star is, perhaps, the most common and natural fate for planets in the universe. A quiet, inevitable finale, playing out in billions of systems across our entire galaxy. This process forces us to look anew at the very concept of the habitable zone, the belt of life. Even if a planet is in the perfect place for life to emerge and be sustained, it does not guarantee it an eternal and safe future. If its star is a future red giant, then this zone will shift over time, and the planet itself may be doomed. The search for extraterrestrial life is always a search within a specific time window, between the birth of a system and its inevitable demise. The cradle of life, which will inevitably become its fiery grave over time. Let us return our thoughts to our sun and its distant future. When it becomes a white dwarf, the surviving planets, Jupiter, Saturn, Uranus, Neptune, will continue to orbit it in the cold void, but their dance will not be eternal. Constantly emitting gravitational waves, they will very, very slowly lose energy and spiral closer to the dead sun. After trillions and trillions of years, even mighty Jupiter will be torn apart and consumed by what remains of its star. In the end, the star will reclaim all of its children, down to the very last one. This final act of cannibalism will occur in near total darkness and absolute cold. The universe by then will have greatly cooled and expanded, the stars long since extinguished. The white dwarf will no longer be white, but black, emitting neither light nor heat. The absorption of the last planet will happen in silent, impenetrable darkness, without witnesses, like a final quiet breath in a dying, empty world. It will be the loneliest and quietest end imaginable. But even then, the story will not end. It will simply transition to another level. The matter that composed the last giant will become part of the black dwarf, the last material object in the system. And this black dwarf, according to some theories, over unimaginably long periods of time, may itself decay into elementary particles in a process called proton decay. All matter will return to its original state of pure energy. The great cycle will end only, perhaps, to begin again in some other new universe. Every star we look at in the night sky is a potential cannibal, with a past or a future. Every tiny point of light carries within it a history of the past and a prophecy of the future. Some of them, perhaps right now, at this very moment, are consuming their planets, and the light from this event is only now traveling to us through the void, to reach Earth in thousands of years. We see only a frozen frame in the long, endless film of cosmic life. The night sky is a vast museum of destinies, where every exhibit is an entire sun with its own story. This knowledge should not frighten or trouble your mind. It should evoke a sense of humble, quiet reverence. We live in a brief, blessed moment of cosmic stability. Our planet, our system, our sun, all exist in a fragile, precious equilibrium. We are the children of a calm star, and we have this time to look at the sky and marvel at its mysteries. A time to realize ourselves as part of this great, incomprehensible, and beautiful whole. When an astronomer points their telescope at a distant star and sees in its spectrum a hairline-thin line of lithium, they see not just a chemical element, they see the ghost of an entire world. They mentally touch the history of a planet that is no more, its mountains, oceans, atmosphere, which have now become merely a part of the featureless stellar plasma. This is the most poignant and sorrowful form of archaeology imaginable. It is the reading of epitaphs written in light on a tombstone made of pure fire. the consumption of a planet is not only a physical, but also an informational end, an absolute erasure. All the complexity, all the history that could have been recorded on that planet, from its unique geology to perhaps its fragile biology, is wiped away without a trace. The universe, in this sense, ruthlessly and efficiently erases its drafts. All that remains is a crude chemical composition, like a brief summary of a book burned to ashes. It is the Library of Alexandria, burning on the scale of an entire world, again and again. Imagine a planet with an advanced civilization, possessing knowledge of astronomy, and watching as its own sun begins to inexorably swell. What is it like to know that your world is doomed, that the very sky, the source of life, is becoming your enemy? This thought lies beyond our experience, but it is woven into the very fabric of the cosmos. This is the ultimate form of existential horror, but at the same time, it is also the ultimate form of accepting the inevitable. A fate that cannot be changed, but can only be met with quiet dignity. Astronomers have even coined a special term for this process: engulfment. It sounds dry and scientific, but behind it lies all the poetry and tragedy of this grandiose phenomenon. It is a word in which one can hear the roar of an approaching fiery surf, the abyss opening up beneath the feet of an entire world, and the silence that follows. A single word to describe the end of everything that was once a home. In the constellation Auriga, there is a mysterious star that is regularly, once every 27 years, eclipsed by something enormous and translucent. It is Epsilon Aurigae. One theory holds that we are seeing a gigantic dust disk, orbiting the main star's invisible companion, perhaps another star surrounded by the remnants of destroyed planets. Every 27 years, this funeral shroud passes in front of the main star, obscuring its light and reminding us of its mystery. We see the shadow of a graveyard of worlds, cast upon the face of a living, shining star. Even orphan planets, ejected from their systems and doomed to eternal wandering in the interstellar darkness, can bear the traces of this process. Some of them could have been ejected at the very moment their star began to turn into a red giant. They are cosmic refugees who escaped a fiery flood, but are doomed to an eternal winter, darkness, and endless loneliness. Their freedom is an eternal exile in the silent void. Think of the unimaginable timescale on which these events unfold. Our civilization has existed for only a few thousand years. Life on Earth, a few billion. The life of our sun, 10 billion years. And the process of one planet being consumed can last for millions of years. We are trying to understand eternity with only a single brief moment at our disposal. Our knowledge is but a tiny island of light in a boundless ocean of ignorance. But even this small, trembling light allows us to see the outlines of other distant shores. Every atom of iron in your blood was born in the heart of some ancient, long-dead massive star. When we look at our hands, we see matter that has traveled through the cosmos, was part of stars, nebulae, and perhaps other planets. And when our sun one day engulfs the Earth, these atoms will simply continue their endless journey, returning to the stellar womb to one day become part of something new. We are but temporary, thinking custodians of ancient stardust. This cosmic cannibalism is a harsh reminder that the universe was not created for us and has nothing to do with us. It lives by its own laws, majestic, indifferent, and beautiful in their indifference. On its scale, the fate of a single planet, a single civilization, is merely an imperceptible ripple on the water. But it is in this ripple, in this brief, fragile moment of conscious existence, that the entire true miracle lies. The value of each moment is defined by its inevitable end. Peering into the spectrum of the star Kronos, scientists were able to determine not only the presence of foreign elements, but also their proportions. It turned out that the planets it had consumed were rocky, not gaseous. It preferred worlds similar to Earth or Mars. This, of course, is not a conscious choice, but merely a consequence of the gravitational dynamics of its system. But the very image of a star that selectively devours rocky worlds stirs the imagination. A silent cosmic gourmet whose favorite flavor is molten rock and boiling metals. Observing the chaotic dimming of the star Rz Piscium is like watching the demolition of an old building from afar. We do not see the explosion or destruction itself, but we see the clouds of dust that rise into the air and then slowly, over a long time, settle. This dust, orbiting the star and obscuring its light, is all that remains of a complex planetary architecture that was built over billions of years, a cosmic ruin, visible in a telescope's eyepiece as a mere flicker of light. When a white dwarf pulls in the debris of a shattered planet, it does not simply fall onto it. It forms a dense accretion disk in which matter grinds against itself at immense speed, heating up to millions of degrees and beginning to radiate in the X-ray spectrum. Thus, a dead, cooling star, by devouring the remains of its planets, flares up for a brief moment with an invisible, high-energy light. This is the silent death scream of a planet, audible only in X-rays. There are stars that have survived close proximity to a red giant and remained alive. They might have been part of a binary system, and their companion has already passed this stage, swelling up and shedding its envelope. Such witness stars may have a stripped surface. Their outer light layers were torn away by gravity or the powerful stellar wind of their bloated neighbor. They are survivors, but forever marked with deep scars. Their appearance tells a silent story of how close they came to the fire. The fate of the moons of engulfed planets is also predetermined, and they have no chance of salvation. They will either be torn apart by tidal forces, along with their host planet, becoming part of a common stream of debris, or, if they are lucky, they will be ejected into new, chaotic orbits around the star, turning into tiny, lonely asteroids. Our moon, for example, Earth's faithful companion, will share its fate, plunging into the sun along with it. The eternal companion will follow its master to the very end, into fire and oblivion. What happens to a planet's magnetic field when it plunges into a star? Most likely, it quickly collapses under the onslaught of unimaginable heat and pressure. But the very fall of a huge magnetized body into the star's conductive plasma must cause incredibly complex electromagnetic phenomena. Giant currents, powerful flares, local disturbances in the star's own magnetic field. It is a quiet, invisible thunderstorm in the very heart of a fiery storm. A silent magnetic storm in the heart of a fiery ocean, unseen and unheard. Brown dwarfs, these failed stars, too massive to be planets but too light to ignite thermonuclear reactions in their cores, can also fall victim to stellar cannibalism. The engulfment of such a massive object as a brown dwarf can seriously shake up a star, causing a flare comparable in power to the merger of two full-fledged stars. This event leaves a deep mark on the life of the engulfing star. It is a drama when one star eats another, albeit a failed one. Perhaps some heavy elements found in the most ancient stars of the universe which should have consisted almost of pure hydrogen and helium, got there in precisely this way, through the engulfment of the first earliest planets formed at the very beginning of time. This means that stellar cannibalism is not just a phenomenon of the mature universe, but a fundamental process that has been going on since the very birth of the cosmos. A ritual as ancient as the stars themselves, and as eternal as gravity itself. Think about the silence of this process. We speak of explosions, flares, and catastrophes, but in the vacuum of space, there is no sound to convey them. The demise of an entire world, with all its mountains and oceans, occurs in absolute unbreakable silence. The whole drama unfolds only in the silent play of light, gravity, and matter. It is a silent opera whose music is the slowly changing brightness and color of a distant, tiny point of light. The greatest tragedies of the universe are absolutely and completely silent. The speed at which a planet spirals inside a red giant directly depends on the density of its outer layers. If the star's atmosphere is very rarefied, the planet can exist within it for hundreds of thousands or even millions of years, slowly descending as if in a dream, before it reaches the denser layers and is quickly and finally destroyed. This is not a fall, but a slow, viscous immersion, a long, unhurried agony stretched across entire geological epochs. What if the consumed planet had rings as beautiful as Saturn's? They would most likely be destroyed first, as the most fragile part of the system. As it approached the swelling star, the ice particles of the rings would evaporate from the heat, and the rocky ones would be swept away by the intensifying stellar wind. The loss of the rings would be the first silent sign of the impending catastrophe for hypothetical observers. The planet's majestic adornment would disappear first, like a crown knocked from the head of a doomed king. The study of cannibal stars helps us understand not only their fate, but also our own, very distant but inevitable one. By understanding how and why stars consume their planets, we can more accurately predict the future of the solar system and the ultimate fate of Earth. This is not just detached, abstract knowledge. It is an attempt to read the very last chapter in the history of our home, written billions of years before our appearance. It is a way to peer into the end of time, to better understand and appreciate the present. The light from the star Kronos, the famous devourer of worlds, takes about 350 years to reach us. This means we see it as it was in the mid-17th century on Earth, during the time of Newton and Huygens. Perhaps in that time, it has consumed another planet or a large asteroid, and the light from that event is already on its way to us. We are observing the past, and we will never know what is happening there now. Every astronomical observation is a letter from the deep past which we read with an immense delay. If a star consumes a gas giant rich in hydrogen, it can briefly give it a second wind, rejuvenating it. The fresh fuel falling onto the surface can mix with the star's matter and trigger local but powerful thermonuclear reactions, causing the star to temporarily flare brighter. The planet, in a sense, becomes the final sacrifice offered on the altar of fire to prolong its slow burning. A life given voluntarily or by force to momentarily postpone inevitable death. Imagine a binary system where both stars have already died and turned into white dwarfs. They continue to orbit each other in the cold darkness, emitting gravitational waves and slowly but inexorably drawing closer. If any planets or asteroids remain in this system, their orbits will be constantly distorted by this macabre dance of two dead suns until they are either ejected or torn apart by their combined gravity. It is a dance of the dead that continues to destroy everything left around it. For astronomers, the discovery of a white dwarf polluted with heavy elements is like finding a perfectly preserved dinosaur fossil. It is a direct physical remnant of the distant past that can be studied in minute detail. The chemical analysis of such a dwarf's atmosphere is like the genetic analysis of an ancient extinct creature, allowing us to reconstruct its appearance and habitat, which have long since vanished. This is true stellar paleontology, reading history from ashes. The very fact that we can sit here on a small rocky planet sheltered by a thin film of atmosphere and contemplate the fate of worlds trillions of kilometers away is a true miracle. Our mind is an instrument that the universe, perhaps by chance, created to know itself. In us, in our consciousness, the cosmos looks at itself and marvels at its own grandeur and complexity. We are the eyes and thoughts of the universe, its fleeting self-awareness. Some stars, called variable stars, pulsate with incredible clockwork precision. If such a star were to engulf a planet, this event could disrupt its fragile internal equilibrium and forever throw off the rhythm of its pulsations. Just as a strong blow can make a perfectly tuned bell vibrate differently, with a jarring sound, the engulfment of a planet can forever change the song of a star, adding a note of sorrow to it. Even a single note, out of place in the eternal melody of the cosmos, tells an entire story of tragedy. Perhaps right now in our Milky Way galaxy, there are civilizations that have encountered this problem and are searching for a way to escape their expanding star. Are they building giant arc ships to fly to other stars? Are they trying to move their planet to a more distant, safer orbit using unimaginable technologies? Or have they simply resigned themselves to their fate, creating final works of art in the face of a fiery sunset? We will never know, but the very thought of it fills the night sky with myriads of unspoken silent stories. A cannibal star is not a monster from a scary fairy tale. It is simply a star following its natural life path. It is like a tree that sheds its leaves in autumn to grow new ones in spring. By consuming its old, cooled planets, it recycles their matter, and, in dying, prepares the ground for the birth of new stars and planets in the distant future. It is a cycle that is greater than the concepts of life and death. It is the calm, steady breath of the cosmos, where every exhale is an end, and every inhale is a new beginning. The outer layers of a red giant can be even cooler than the surface of our sun, but they are incredibly vast and extend for millions of kilometers. A planet plunging into them does not burn up instantly in a blinding flash. It slowly cooks in a gigantic rarefied cauldron of plasma, gradually dissolving like a sugar cube dropped into a cup of hot tea, which slowly disappears, leaving only sweetness behind. A quiet, slow dissolution into fiery eternity, without pain and without sound. Even if a planet is completely vaporized in the star's interior, its most refractory elements, such as tungsten, osmium, or iridium, can for a time survive as droplets of molten metal, swirling in the convective currents of the stellar atmosphere. These are fleeting, fiery tears of pure metal, all that remains of the dense core of an entire world that was once as solid as rock, the last most resilient and unyielding fragments of a former greatness. Someday, billions of years from now, astronomers from another distant galaxy might point their incredible instruments at the place where our sun is now. They will see a dim, cooling white dwarf, and by analyzing its light, they will detect in its spectrum the faint absorption lines of silicon, oxygen, magnesium, and iron. And one of them will say, "This star once had a rocky planet similar to ours." This is how the story of Earth will end, as a single short line in the scientific report of a distant future scientist. But that day has not yet come. For now, our Sun is a calm, stable yellow star on the main sequence. For now, the Earth spins on its predictable orbit, giving us the change of day and night. For now, we have this night to look at the stars, and the minds to try to understand them. And in this quiet respite, in this fragile, precious moment of peace, lies all the ineffable beauty of our existence. Breathe in this moment. It is all we have. It is ours. This story of stellar cannibalism is not a bedtime story meant to frighten or alarm. It is a lullaby of cosmic unity, about how everything in the universe is inextricably linked, star and planet, beginning and end, destruction and creation. Everything dances to a single, eternal, slow, and majestic rhythm, to which both the atom and the galaxy submit. A rhythm to which it is so easy to let go of all thoughts and fall asleep. Think of the star that devoured its planet and now carries its substance within itself. Now it has become something more than just a star. It is a living memorial. It is a fiery tomb. It is a cradle for future worlds that will be born from its dust. It continues its journey through the galaxy, holding in its blazing heart the silent memory of what once orbited it in the silence and darkness. A quiet light in the night, full of untold, long-forgotten stories. The absorption of a planet rich in heavy elements can slightly change a star's color. The addition of these elements to its photosphere, like an impurity in a pure crystal, can make its light slightly more red or orange than is typical for its type. It is a subtle, barely perceptible change, but it is there. The star, quite literally, changes its appearance after its meal, as if donning invisible mourning for the world it has consumed. The color of grief, which can only be discerned through the prism of a spectrograph from hundreds of light years away. If we could hear the gravitational waves from a planet falling into its star, it would not be a loud bang, but a sound increasing in frequency and volume that astrophysicists call a chirp. It would sound like a rapid wail that abruptly cuts off at the very moment of merger. It would be the sound of the orbit itself, shrinking faster and faster until it disappears completely into the fiery abyss. A planet's death song, sung in the universal language of gravity and space-time. There are so-called zombie stars, white dwarfs in close binary systems that pull matter from their still-living companion. Having accumulated enough mass, they can exceed the Chandrasekhar limit and explode as a Type Ia supernova. This is also a form of cannibalism, where a dead star siphons life from a living one, only to ultimately self-destruct in a blinding flash, visible across the entire universe. A resurrection from the dead for the sake of one last final and dazzling death. For a hypothetical observer on a planet falling into a star, time would slow down due to the extreme gravity near the massive body. From his point of view, the rest of the universe around him would accelerate, flashing by in moments, while his own fall would stretch into an eternity. This is the last strange distortion of reality before complete and final oblivion in the flames and immersion into eternity that for the one falling lasts an eternity itself. Ultimately, in unimaginable trillions of years, all stars will burn out, all planets will be consumed by their dead suns or freeze in eternal darkness. The era of the heat death of the universe will come, an age of black holes and cold. But even then, in this endless darkness and cold, the very structure of space, the very memory of light will remain, the memory of stars that once burned and of worlds that orbited them. This memory, this knowledge is us, here and now. Stellar cannibalism is not an anomaly or an exception, but an immutable norm. It is the natural order of things. It is the universe's way of maintaining equilibrium, redistributing resources, creating new from old. It is cosmic ecology on the most grandiose and ruthless scale, where nothing is superfluous. Nothing goes to waste in the great economy of the cosmos. Everything is put to use. Scientists studying the chemical composition of polluted white dwarfs have made an astonishing discovery. It turned out that the chemical composition of the asteroids and planetary fragments they absorbed is very similar to the composition of asteroids in our own solar system. This suggests that the processes of planet formation may be universal. That somewhere out there were or are worlds very similar to our own, with the same rocks and metals. Brothers and sisters of Earth, whom we know only by their dust on the face of a dead star. The next time you look at the night sky, remember that you are not looking at a static, frozen picture. You are looking at a vast stage full of slow but continuous action, where dramas of epic proportions unfold. It's just that they happen so slowly and so far away that to us it looks like a motionless scattering of quiet, serene diamonds on black velvet. Each diamond is a volcano ready to erupt, or a grave ready to receive an entire world. Imagine a huge ocean wave rolling onto a sandcastle built by a child on the shore. It is neither evil nor good. It is just a wave following the laws of physics. So too a star, as it expands, consumes its planets. It is simply a tide of fire that washes away everything in its path, following the fundamental laws of nature. And in this absence of malevolent intent, there is its own stark, yet profoundly serene grandeur. The absorption of a planet can create complex convective currents within the star, like a spoon stirring a thick soup. These currents can affect the star's magnetic activity, causing the appearance of giant star spots or powerful prominences on its surface. The eaten world causes a kind of indigestion in its parent, which manifests on its surface. An echo of a distant doom, manifesting as fiery storms on the star's surface. Some of the dimmest stars we see with the naked eye are actually very bright, but incredibly distant red giants. Perhaps some of them are expanding right now, and the light we see left them at the very moment when their fiery edge was already touching the first, closest planet in their system. We, without knowing it, are witnesses to the beginning of the end. We are unwitting, belated witnesses to the beginning of the end of distant worlds. This process reminds us of our own fragility and vulnerability. Our civilization, our history, our very life, all of it exists thanks to the thinnest layer of atmosphere on a small rocky ball orbiting a remarkably stable and predictable star. Any of these conditions could change, and this realization makes every day lived, every calm breath, even more valuable. The preciousness of the present moment, realized through the prism of ruthless cosmic eternity. As a red giant expands its habitable zone, the region where water can exist in liquid form on a planet's surface shifts further and further from the center. The icy moons of outer planets like Europa or Enceladus in our system may melt under the increased heat. For a brief period, by cosmic standards, conditions for life may arise on them before the star finally dies. The last fleeting ghostly chance for life on the very outskirts of a dying system. Stellar cannibalism is part of the grand symphony of the cosmos. In it, there are quiet, gentle passages, the birth of stars from gas nebulae. There are long, sustained, calm notes, billions of years of stable life on the main sequence. And there are powerful, tragic crescendos, supernova explosions, and the engulfing of planets. And all of this together creates the incomprehensible, yet harmonious music of the universe. Music that we, humanity, are only just beginning to learn to hear and understand. And now, as the knowledge of these fiery fates and cosmic cycles fills your mind, let it slowly dissolve, like mist at dawn. Let the images of distant dying stars transform into quiet, softly twinkling lights behind your closed eyelids. They are not a threat. They merely remind of the great eternal peace that lies at the heart of all that is beyond the hustle and anxieties. Every star is a cradle, every planet is a quiet dream, and the entire cosmos is a deep, all-encompassing silence. The light from a star that consumed its planet many centuries ago travels to us through the cold void, carrying this ancient secret within it. It carries it not to alarm, but to lull, to show that even in the most grandiose and fiery events of the universe, there is an immutable order, its own slow rhythm, its own inevitable and calm conclusion, just as every day, every life, every thought has its own quiet, natural end. This odyssey to the cannibal stars is coming to an end. We have seen that destruction is but the other side of creation, and the end of one world is merely the lull before the beginning of a new one. The universe breathes in its own incomprehensible rhythm, and we, for just a moment, were able to listen to this breath. May this knowledge bring you not anxiety, but a deep, all-encompassing peace. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul after another. And now, just breathe. Let your eyes grow heavy, and may the quiet glimmers of distant stars lull your thoughts. Good night.